Okay, it's 12:33 in British summertime, and it gives me great pleasure to welcome Anthony Chabertoni, Mr. IBM DB2 SWAT team. He's come to present to us in his busy schedule on new 2025 SWAT tales. And when Anthony speaks, you will be wise to pay attention. So thank you very much. It'll be a great show today. Over to you.
All right, thank you, Marcus. Can everybody hear me? Marcus, everybody hear me okay?
Yeah, no
Always
trouble.
wanted
Loud and
to,
clear.
okay. Perfecto, perfecto. So as Marcus said, and thank you for the introduction, Marcus, Anthony Shabatoni. I now run the SWAT team. This presentation, my goal in this presentation an evolution, right? So if you see this presentation with this title today, it could and will change the next time you see me, because my goal is to, as I'm doing studies with folks in my social circle or just around the lab and seeing things that bother you or are important to you or hot topics, I'm adding and subtracting constantly. So today, what we're going to go through, if I can get my mouse working, is really three major topics. One is DB2 rebind with access path stability. That rebinds has been one of these things that keeps coming and going and going and coming as a topic. So I want to talk through some confusion and some ideas around to share with you to take advantage of for your shop. If you're using IBM storage, and there's a group of the percentages between IBM storage and other storages are somewhat split, but if you're using IBM, we're going to talk about Z hyperlink, which is special connection from zOS to the DASI subsystems, and I'll tell you the goods, the bads, and what we need to talk through from a DB2 perspective. And then the continuous availability topic. What I did this time was just took a couple topics out and put a couple topics in that were important. And that part of it is more around fast restart and what happens when a member ends. A couple slides there. And lastly, and my favorite, and it keeps coming up over and over again in the last 12 or 18 months, is asynchronous lock duplexing. And we'll talk through the technology and some things around that. So with that being said, I have 45 minutes. If you have any questions, my good dear friend Marcus will be able to look at the chat room and let me know, and I can stop along the way. So if we start with this, when is a DB2 rebind necessary? So as we're going through the version migration from 12 to 13, and if you haven't got to 13, you have till December 31st of 2025 before we go out of service. But after you go through successful migration, and today, since we're in this realm of 12 to 13, if you run a version 12 bound package on version 13, it will run quite well. But during that run process, we have to do a couple different things. One, the fast column processing, SPROCs, IPROCs, UPROCs are disabled in the new release. And some people just recently had a customer pretty much shocked me for the importance of this. When they went into 12 to 13, they heavily noticed their SPROCs, UPROCs, and IPROCs weren't there. They were disabled. And so they had to kind of escalate up through and do their rebinds in 13 sooner than what most people would do. The other piece of it is we have this wonderful technology that we call puffing. A customer yesterday told me he referred to it as a fatty. And what happens is a version 12 package has to puff up. And we have to take it and make it a 13 runtime structure. And so we had to puff it, and there's some CPU around that. There's some overhead around that. So in both of these scenarios, a simple rebind is necessary to eliminate the puffing and the overhead with the slight overhead with that, and also to re-enable the SPROCs, UPROCs, and IPROCs. Also, packages can be invalidated when you do online schema changes. We're going down that path. And so with the technology from non-UTS to UTS conversions, and then we have UTS partition by growth to UTS partition by range conversions. And as of function level 507, we could go from PBR to BBG and PBG back to PBR all in one reorg with a stack of materialized changes. But again, though we invalidate the dynamic statement cache, invalidate the packages. So you're going to need to do a rebind. If you want to take advantage of, you have all your packages are release commit, and you want to take advantage of protected threads thread reuse in the Kix environment, or high performance DBAT. To take advantage of this CPU savings opportunity, again, you need to rebind if you haven't already done so. Then the last two, one of them is if you have the appetite to want to elevate your Apple compat across the board. Some people will get to a function level, wait a period of time, and then they want all their packages to be at a elevated Apple compat. Some customers, not needed, but some customers have a preference of after every time they apply maintenance, they want to rebind. And when you apply maintenance, you have two things that you could get with a rebind. One, if you let the optimizer do whatever the optimizer does, you get a new access path based on the code. Or more importantly, what people do for or looking for is runtime improvements within a maintenance set of maintenance. So all things that you're going to need a rebind. It's part of life. If you've been around long enough, you heard Roger Miller up on the stage talking about his speech of to bind or not to rebind. Again, you're going to have to do it at some point in time. And so now that I kind of set the table that we're going to have to do it, what is your appetite for DB2 access path change? Now, I put it in green, it's not red, and because it's a decision. And if I'm in a room with a group of people, with even in the same organization, we can have differences of opinion. And the question is, the first one, are you defensive? I'm doing these infrastructure type of changes. I have to do a rebind. I want the same access path. I'm gonna just get a rebind done. Some people will have a sense of a little bit of conservative, press the envelope a little bit. And then some customers, and there's nothing wrong with this, will say, you know what? Every single rebind, I'm going to let the optimizer do its thing. I have good stats. I have good housekeeping. I trust the optimizer. So even though I put the middle one conservative, normally it's left or right. It's I want to get this rebind. I can't get a new access path. Another group of people are on the right with the optimizer. I'm gonna let it do its thing. So in this discussion, we'll talk about the defensive posture. The defensive posture is we have some different options. And we came out years ago with some parameters, and I'll start with access path reuse, AP reuse. And you have three options on AP reuse. and that would be option one would be error. So when I'm doing the rebind, if the optimizer will do everything humanly power, or I should say humanly, within its computer AI mind, it'll do everything possible to get the same access path back. So if there's 10 SQL statements, all 10 will have to come back. If they did, we're fine. The rebind successful. If any one of those fail, the rebind will fail. Warn is if we do the rebind and we get one of the access paths, we'll say access path SQL statement 10, all 9 get the same access path. And then SQL statement 10, for whatever reason, the index is gone, or in a release bind that access path is not valid anymore, then we will put everyone back to its original access path, and only that one access path will get it. That the one SQL statement will get a new access path, and then none. We're just telling the optimizer, go do your thing. And so there's the 3 bullets behind that, and then the warning, and then the none. So that's there for when you upload the presentation. And so with that, that's at the rebind perspective. So also we have access path compare, AP compare. Again, the 3 options. Again, AP compare error, optimal access path will be selected. There'll be no guarantee. So we're telling the optimizer, go and do get the same to get an access path. And if it's different than what you have, it will fail. And which is different than before, it would just fail straight away. This time, it would do everything possible to get that access path. This time along the way, we're saying, hey, go find what the best access path is. And if it's different, fail. And again, Warren will go out and see, again, same process. And then if one of them is different, if we can't get it, we'll get to a new access path. The rebind will be successful and will report on the new access path in the plan table. And again, none, we let that optimizer do its thing with no caveats around it. So I will take a and then with all 3 of those there, again, you let the optimizer do its thing. So I'll take a breath. If anyone has any questions, post up in the chat. Is there anything yet, Marcus?
No, nothing yet.
Okay. So what do we do about this? If you've been around long enough around different management, we did a rebind for an operational infrastructure type of change. Access path changed. It caused a production outage. And what does your executive say? Don't ever let this happen again, or else. So with that defensive posture on the left-hand side, the recommendation from that perspective, and again, you have to go in with that perspective, is go in with AP reuse of error. That should be your default for those type of rebinds. If you're going to now reestablish the access path. If you're going from version 12 to version 13 and using the AP reuse of error, please take a look at PH63063. I work with a customer that had the SPROX that they wanted to fast calling processing procs. They have to rebind, and they went in with my recommendation with AP reuse. I was thinking, since they just recently rebound most everything, that they would get a 90 some percent success rate with AP reuse of error. And to my disbelief, it was like 60%. I was freaked. And it was because we had a little bit of, in the compare code, we had a little bit of a problem with comparing a version 12 to version 13. And so that was corrected with this APAR. AP compare that doesn't exist, only with AP AP reuse of error. So then it said, okay, I have 1,000 packages. I went to version 13. I did a rebind with everything, and maybe we'll say a handful of those packages failed. What do I do? Shavatoni, I have these failures. I did what you told me to do. I really want to get these um, packages rebound on version 13. So the next step would do a rebind with AP compare error explain only. And as long as you have the PH 61970 apply with phase-in support rebind with a package explain only, what will happen is we won't rebind, but we will do the explain only, and when it fails, it will tell you what it failed on. Where AP reuse of error, it will fail because since the rebind was unsuccessful, it doesn't write to the plan table. So AP compare error does, and you can understand why that occurred, and you can then determine the next course of action. If you're good with that, say, oh, Marcus, Marcus is one of his packages fail with one access path. Optimizer couldn't get the access path back. We look at the reason, and Marcus says, "Hey, I'm good with that." Then you could do AP reuse of Warren, and going back to everything, the 9 SQL packages, SQL statements will get the same access path, and the 10th one will get the new one, and you'll know beforehand, and then you'll see afterhand with the explain table. So then that's the defensive mechanism. Now you're back on 13. You got, or your mainnets or your invalidations. And so now, so okay, I'm there, I'm running my code. I got rid of the puffing, re-enable my fast column processing. Now this is where I think folks should take a look at the next step. And after successful rebind, then go back through and do the normal rebinds to see what the optimizer can give you. Various people have different ways, but if you're using DB2 only, you can look at rebind, AP, compare Warren, explain only, and look at the access paths, and then actually let the optimizer go if you're happy. So kind of progress your way through a couple steps, and that's with the ultra conservative approach.
Hi, Anthony. There's a little question popped up
Okay.
from Darren. He says, just thinking aloud, statement level versus package level dependency. Does any of that have implications here for rebind AP reuse options?
So I have to go back, Darren, and look at me thinking out loud. You're putting me on a spot, which is good. So it's going to happen. The phase in will happen when we invalidate it, and I need to go back and see what the default is. I have it on another slide someplace, Darren. So I'm not positive what the default is behind the scenes, but I'll get back with you on the email on that. Anything else, Colin, in the chat?
Nope, that's the only question. Thank you.
Okay, thank you. So I want to switch gears. Z hyperlink. So Z hyperlink, it's the flavor of the last 9 to 12 months, and I'm probably getting questions and evaluation questions on this at least once a week, if not more. So what is Z hyperlink? From an IBM perspective, Z hyperlink is a direct physical connection between DB2 Z server and the storage subsystem using the same cabling as short distance coupling. And reads are exploited from a DB2 perspective, and we're selfish because we're in a DB2 track. Reads are exploited by DB2 for synchronous reads, and writes could be exploited by the DB2 active logs. Across, those are two biggest things that we could take advantage of. And as we look through that, the ultimate thought here is I will speed up my IO, but potentially add a little bit more CPU. And we'll talk through that a little bit. And when I say a little bit of CPU is instead of going through the normal process of dispatching a running task, IO interrupt, a CPU queuing, host cache disruption, small IO service time, we make that request across that short cabling and we spin and we wait. So it depends on your data. What we're seeing is, and we'll have some numbers here, there's some good opportunities around it. Normally, for the most part, the cost is a noise in your system and your benefits are good. And we'll look at that, and it depends on what your objectives are, whether you should look at exploit it. If elapsed time is not important to you, then I wouldn't spend the time to do it. But if elapsed time is important, then we should look at it. And again, once we enable it, it should be transparent from a DB2 perspective when this is going on, other than the performance numbers. So again, it's a direct connect physical connection. And then we have the Z hyperlink reads where we're doing the read from cache and we're spinning and waiting for it. And the second piece of that would be the Z hyperlink writes, and that's for faster writes to the active logs when we either at commit time or force log write. Again, Z hyperlinks can be used with Metro Mirror in conjunction with Global Mirror in both the 3-site MGM and also the 4-site. And then another side benefit of it is you can have a consistent read for the Metro Mirror secondary. So if you're running the secondary after a hyper swap on the local system, you could read, since it's synchronous, you could do the reads on the Metro Mirror secondary, which could be a little bit more efficient. But today we're going to talk about the reads and the writes. And so here's where we're talking through the elapsed time versus CPU cost. And I'll just kind of walk through, not even walk through all those, but again, what is important to you? If someone were to corner me in a hall and say, I want to take advantage of this new technology, my first question is why? And if the answer is, I want to speed up my IO processing, elapsed time, I'm good. If you come to me, if Marcus comes to me or Colin comes to me and say, you know what, Anthony, every CPU second, I could sacrifice IO for CPU. I wouldn't spend my time on it. Another good benefit is customers that they have a critical batch window. Batch is normally a good benefits here. And we have one customer says, you know what, I'm going to toggle on for my batch and I'm going to get that benefits. I'm going to turn it off during my onlines because I don't see as much benefit. And then again, that little bit of that added time on that spin. Now, you'll see in a couple of charts from now some performance numbers on the upper right-hand corner. One piece is important here is the fact that if the workload's DRDA, and you're getting the benefit of Z hyperlink reads, and you have the 60% zip offload, any spin on that request CPU spin will be 60% zip eligible. So that makes the proposition a lot better to our side. But again, most customers are doing some evaluation numbers and then going with it. So the log writes, if you look at the number of log writes that are out there, the percentile of a transaction, if you take an accounting record and look at the class 3 times, that log write time is normally a very small piece of a transaction. So typically, if you look at it from a transaction by transaction perspective, you're probably not going to see, on the most part, a tremendously big savings. But again, as we talk through with various people, if you save a little bit, a million times a day, that's a benefit. So there is some savings there. I just tell people to take it accordingly, knowing that it's a small piece of a transaction. What we see now, if you look at typical online OLTP DRDA workload, we're pretty consistent. And I probably looked at in the last 9 to 12 months, 30 or 40 customers set up accounting data. We're always around that 10%, 8 to 10% to 12% IO savings with DRDA. So if during your online data, elapsed time is important, and then any additional cost would be zip offloadable. Also, what you see on the right-hand side is customer running batch on one system. Again, batch is a great exploiter of it. And we see any TSO connections or DB2 call, you could see upwards around 30%, sometimes 40% IO savings. So if that critical batch window is important to you, that's another benefit. Kicks, a lot of Kicks workload. And if I look at Kicks holistically, normally it's a small savings. And it's consistent at a global level of normally a couple 3%. Now, with that being said, if my storage guy Nick Clayton was sitting next to me from IBM, he would say there's, if you take a further look at it, there's always some transactions that are better than the others. So we encourage to kind of look at it from a connection based down. And then if you want to start looking at, you get good savings for DRDA and batch, and you start looking at Kicks, you'll find some transactions that are good exploiters of it. And then the question of all my friends out there, and I say I resemble you because I always ask the same question: is how do I judge the overhead of this? And there's no easy way, because you'll see some or you'll see some time in the class 2 the class 1 and class 2 CPU, but it's all, you normally don't, you see that, but you're also, you have to look at the overall system, you got to look at the IO subsystem. It's hard to really look at any one individual component, so you have to try to take a snapshot of 2 different timeframes, with and without it, at the system level coming down, and not the granularity coming up. You get the granularity coming up, we're going to probably debate until Christmas and New Year's comes, because it's hard to judge each granular piece. So if you're doing this, try to find a time frame in production that is with it on and with it off, and try to compare it from there at that system level, big picture down to a smaller picture. And again, DB2 reports, IO reports, batch jobs, or a sample job, it's all variable and you'll drive yourself crazy. And trust me, I drove myself crazy to try to get that number. And it's the only real answer is try to make sure everything is the same and do it at the system level down. And so again, here's some numbers around that, the performance numbers, the CPU usage on that. And the last slide on this topic would be with this process and with the benefits behind that, how do how are clients adopting this? And so you can control it with a storage class, eligible data sets, and then you can selectively enable some data sets to play with it and be confident. Some customers will micromanage this. And again, we talked through and had many debates and discussions. It will drive you crazy. And if when you start seeing different numbers, you may be inclined to oh, I'm not confident, I'm going to turn it off. So that's not a good approach. Five, some customers will do a stage approach. Maybe put it on one LPAR, one set of DB2 members for a day, an hour, and turn it off and look at it. Maybe do it during batch and say, you know what, I know I'm seeing benefits. I don't want to see any negative benefits. So you could kind of do that method and incrementally go in and out of it. And then the last option that I tell people, if you're high kicks transactions and no DRDA, so you just get a little bit of savings during the online day, but you have that critical batch window, then build a job that every day toggle off and on. So what during the online day, turn it off. At 6 o'clock, 7 o'clock, or 10 o'clock at night when batch kicks in, turn it on. So there's different things you could do behind that to minimize your risk of implementing. But so far, any CPU increase has been somewhat noise, and the adoptions have been when people have gone this route. And the key is elapsed time is important to them. It's been a good experience. So I'll take a breath, take a sip of water. Marcus, if Colin, if there are any questions, let me know.
Nothing yet.
Okay. I hope I didn't confuse you on that topic. I'm trying to make it consumable as possible.
Sorry, I'm just scribbling down some notes on it and asking somebody about it as well, if we've got it or not.
Okay,
It's
cool.
all good activities while listening.
Good. And you know how to get a hold of me. So, and going back to that, so we do have the ability that there's various different products out there, but what we have done here, if we could take an accounting report and see some metrics around that, and we could run reports based on the accounting data and make some good estimates. And what we're seeing is the estimates and the reality are pretty close. So if you're worried about that, if in your environment, you could reach out and I could kind of show you what to look at within that. So in the last 10 minutes here, we'll talk about continuous availability. Again, we're talking to this conference, this group of people talking to the choir about mainframe sysplex is a gold standard across the industry, and we purchase and we exploit this, but we can't get true continuous availability because we can't mask planned or unplanned outages. Except again, we talked through where the gold standard. And when we built this infrastructure, we give you the foundation and the infrastructure to build on. But additional ingredients are needed. And we're going to just talk through a few because this presentation is normally an hour and 15 minutes. So I took some of that out and we'll just talk through some of this. And so ingredients are, you do want to have data is sharing across your environment. If you're doing hot cold or Champlex or just running work on one system, you're inevitably going to set yourself up for failure. You want to be able to clone your environments, have two of everything, a minimum of two of everything, preferably more. But if you have two and one goes away, you have redundancy. And then once you have what we call infrastructure and application towers, and then from there is once you have the cloned infrastructure, be able to exploit that with fine-grained transaction routing to the appropriate system that's available. And then on this piece of it is you want to be able to dynamically add and increase available capacity when and or if needed. So if you lost half your system, normally that other half is not sized right out of the gate for production, full production workload. So capacity on demand, CVU engines, or things to that nature need to be in your hip pocket, ready to go. And then we'll talk, the one part is CF structure duplexing that is important here. And the quick, if there is a problem in the first topic that we're going to come up with resolves around that, if you have a DB2 admin, you want to bring that member up as quickly as possible. So I'm just showing you this picture, and I'm just going to touch on it here. Two data centers, halls, sites, whatever you want to call them. In this case, we have two CATs, one each side. So we have two, we were redundant. And we have an external couple facility in hall 1 and an internal in hall 2. Which is a good picture of starter kit of thinking through this, looking at this being a nice picture. So now if you had, in this case, this nice picture, you had a DB2 member failure. What are some things we could do? And so our objective is to use automation to get DB2 back as quickly as possible. So I think that most people that we talk to either are using automatic restart manager in zOS or your own homegrown process behind that, which is to restart, which is good. The item I want to bring up here is in the Z15s and the Z16s, we've introduced an IBM family of hardware recovery boosts. And the stage 1 and stage 1 and stage 2 are available on the 15s, but on 16s, we give you the ability to do recovery boost. If you look on the right-hand side, when a DB2 member fails. So if a member, I shouldn't say fail, when a DB2 member is restarted. So we failed and restarted, and we restarted the master address base. What will happen is there are two zip engines that are reserved on the Z16, and we take those two engines and convert those to a GCP, and we'll give you that boost to get your DB2 member up. Because we want, as well as you do, that member to come up as quickly as possible. And we also have ability to have, let me go to the next slide. We also have the ability to do dump processing. So SVC dump recovery processing, you could set in ParmLive or dynamically set it that you say, you know what, if I have a dump and we are estimating it's going to be X amount of size, I want to use this recovery boost. And I hit enter too quick. If we go back on the DB2 process, you could get 6 recovery boosts per day at 5-minute intervals. So it's a total of 30 minutes per day. And how do you do it? Is from this case, from a DB2 perspective, you'd go into WLM and put in your DB2 address space. This one is DB% repeat master, and we put recovery boost yes. And if your member crashes and on the way back up, if we need it, we're gonna bring these two zips online and give you the juice behind it. It's there's no one that I've talked to that is against it. It's a good thing. Now on the dump side of it, I've just recently been socializing here. You could either potentially every dump, but do you really want to spend all 6 of these on these small dumps? So people are looking at picking larger ones that could be impactful, setting the parameter and getting the boost around that. The other piece of this is we talked about towers approach. So in this environment, in this a CICS environment, you can see these beautiful towers. The data center towers, you have 2 on each side, and you have CPS routing traffic around that. And what if you lost a DB2 member down on the bottom left-hand side, if you don't have anything in place, taking any action, what's going to happen is CPSM, when they're routing from the TOR to the AOR, is going to say, wow, I have this DB2 member, I have this transaction that went from 10 milliseconds doing DB2 work down to 1 millisecond. So not only am I going to route the traffic to that AOR, I'm going to route more traffic to the AOR. So we call that, quote, the storm drain effect. So that not only are you going to get failed transactions, but you're going to get many more failed transactions. So in that aspect, until you get DB2 back, and for the sake of time, I'm going to explode this out. You have a couple different options. One, do nothing and take the failed transactions until that number comes up. Method 2, develop automation. This is, detect that DB2 member has failed, and then I'm going to shut off that AOR activity to that DB2 member until it comes back up. And when it comes back up and the kicks reconnects, then we could open it back up. But that's going to affect everything in AOR, DB2, or not DB2. The second method is with CPSM storm drain. And if you set these values in the DB2 connection setting, at then crit and about event threshold, what we're going to do here is we'll automatically detect the negative 923. And we're going to immediately set this environment to unhealthy. And then we have a timer in the background that if you set a percentile of event crit, no workload, you get to whatever the threshold for event crit. So, I'm going to see if my DB2 member is back. I sent a sacrificial transaction. If it's successful, then we'll send 50% of the workload until we get to the second value, event thresh. If we're still good, we're back to normal. At any point in that equation time frame that you failed, then you would go back to 100% unhealthy and not routing traffic there. So some things to think about. And the last topic that I want to talk through is near and dear to my heart is very, very popular in the last 12 or 18 months. So we have this environment, and you said, okay, if I lost a data center, we'll say hall 1, can I have continuous availability across a data center outage? And most people say, Sabatoni, I can. I have an external coupling facility. I'm doing good. But the problem is, if you lose hall 1, not a CAC, but the CAC plus the external coupling facility, you lost at least one DB2 member, and you lost the log structure. And to rebuild the log structure without an outage, all members, IRLMs, have to be present, and we're not. So we'd go through group restart. So in this case, even though we have externals, and one of the customers I'm doing a study on has 4 externals, because the lock structure is not duplexed, if you lost that hall, they would have a group wide outage, which the executive was quite freaked out about when I told him. So one option would be, not very many people will do this, is I have a third data center where I'm going to put only the lock and SCA over there, which is very costly. Previously, we had synchronous duplexing for the lock structure, which was very painful. It worked quite well, but there's a lot of CPU overhead. But in version 12, we came out with a synchronous lock one duplexing. It's not free, it's not as cheap as simplex, that's going to be the cheapest, but it's the cost performance versus any additional overhead is pretty good. So I'm just going to look at this instead of these being synchronous requests. I just want to kind of go through quick, and I know I'm 4 minutes over, so I'll finish in 1 or 2 minutes. So we get this request comes in for the lock request. It goes to the primary lock structure. At that point in time, the primary gives this lock request a sequence number. And we send that sequence number, and keep it simple for now, to the secondary lock structure, and then also back to XCS, who manages these requests. And so we make that request, we take that, send it to the secondary lock structure and send it back to the application. And during the same process, that number 6 that I just added on there, the secondary lock structure says, you know what? Hey, Marcus, thank you for this sequence number. That's the current one you're working on. I'm going to accept that onto my queue. And I'm going to tell you the last one that I've processed, which is always n-1, maybe n-2. And I'm going to send that back to you and let you know where I'm at. And it happens in the background. And at commit time, what we're going to do is compare, is my record, is that record above and beyond where I'm at? Or if I'm not, and if it's okay, and I know that the n-1, that lock request I'm greater than, I will do the commit without any additional work, which is a good thing. If that is not the case, then we open up a connection request to right from that Db2 member to the second request, and we check until it gets caught up, which is very, very quick. The numbers are very, very good. But all this happens in the background. And so we now, not only can we do asynchronous lock duplexing, but we can even do it over some distance. And so now the benefits, obviously, is we could take advantage of this with minimal overhead, additional cost. You do need some ICF to ICF links. And then here's a piece that I want to leave you on. There is a little bit of a cost. If you look at it, you'll see about in the first sub bullet, you'll see about 1 mic of an additional cost for a lock request. So if you had a synchronous request that took 4 mics, you add 20%, you're going to get about 5 mics. So those requests about additional microsecond. And then the couple facility CPU usage. At first look, you see this number 7 times more expensive. You say, oh, that's a very high number, but you have to take it in context. You have to say, how much percent of the couple facility am I using? 30%. And the lock structure is using 20% of that 30%. So you could only increase 7 times of that 20%. Then you raise a little bit. So normally, but not always, that number of additional CPU in the couple facility is manageable. Now, there are scenarios where it's not, and you have to add more CPU based on where you're at. But you could do that in advance to do that estimate by looking at these numbers. So again, the the returns of what I'm getting from the folks that are implementing it has been very good so far. And they get the continuous availability across a data center failure. And so with that, I want to say thank you to everyone on GSE. I want to say thank you for everybody that attended, and Marcus and Colin. Thanks for including me in this year's virtual conference. And if you guys can take the time, fill out the evaluations. It's important for Marcus and Colin and the team to decide who's going to present. But more importantly to me, I hope they always pick me. But I want feedback to make up my presentations consumable and good for you. So with that, thank you.
Thank you very much, Anthony. Really appreciated your time to be with us today in your busy schedule. As always, an excellent presentation, really useful. Tons of great information. Everybody else, we come back in about 20 minutes, so just enough time for a comfort break and a swift cuppa. And we'll be back in 20 minutes to hear another presentation by Keziah Knopp from the IBM Washington Systems Center. See you soon.
Bye-bye, guys. Have a good day.